Hello guys, welcome to my YouTube channel Civil Lifeline. It's our first lecture on Geotechnical Engineering Part 2. We will learn today basic formulas of bearing capacity evaluation by using terzaghis equations. Okay, so there are the different formulas for each type of foundation and type of strata. So the foundations are divided according to their shapes, as you can see here. So the first is circular footing, second is square footing, third is rectangular footing, fourth is strip footing. And now according to their strata, first is cohesive friction soil. This is also called as a C5 soil. The cohesive friction soil is the C and phi are the independent parameters of the soil strength with no direct relation between each other. The C value come from binding between soil grains and the phi value come from frictions between the grain rolls. So this is known as a cohesive friction soil. This is also called as a C5 soil. And the second is cohesive soil. Cohesive soil means soil has an attraction between particles of the same type of grain and nature. The type of soil is that the particles in between soil sticks to each other. Okay, and the third is cohesionless soil, that is known as a phi soil. Cohesionless soil defined as any free running types of soil such as a sand or gravel whose strength depends on friction between particles measured by the friction angle, that is phi. So that we are divided the foundation as per their shapes and their strata as per the soil nature and the characteristics of soil. We will see now the formulas of using terzaghis equations. So first, according to cohesive friction soil, that is also called as a C5 soil, what it includes? It includes clay, silt clay, sandy clay and clay loam. So we will see the formulas of each by according to their shapes. For the circular footing and with having the cohesive friction soil, so the formula for the QF is equal to 1.3 CNC plus gamma D and Q plus 0.3 gamma B and R, where D is the depth factor and B is the diameter, and NC, NQ and R the value will be given in the problems, and the gamma is the unit weight of the soil. Okay, now for according to the square footing for this, QF is equal to 1.3 CNC plus gamma D and Q plus 0.4 gamma B and R. For the rectangular footing, QF is equal to CNC in bracket 1 plus 0.3 BL bracket complete plus gamma D and Q plus 0.4 gamma B and R. For the strip footing, QF is equal to CNC plus gamma D and Q plus half gamma B and R. There are the formulas according to the shape for the soil of nature cohesive friction soil, that is C5 soil. Next, cohesive soil, C soil, in which the value of phi is 0. Okay, so in problem we are solving, the value of C is also given but the value of phi will not be given. And which type of soils it includes? It includes the clayey silt, sandy clay, silty and organic clay. So now we will see the formulas for the each type of foundation. For the circular foundation, QF is equal to 1.3 CNC plus gamma D. For the square footing, QF is equal to 1.3 CNC plus gamma D. For rectangular footing, QF is equal to CNC bracket 1 plus 0.3 into B upon L plus gamma D. For strip footing, QF is equal to CNC plus gamma D and Q plus half gamma B and R. Okay, these are the formulas for the different types of shape of footing according to the cohesive soil, that is known as a C soil. Now for the cohesionless soil, that is phi soil, in that value of C will be the 0. And what it includes? It includes gravel and sand. For according to their shape, circular footing, for circular footing QF is equal to gamma D and Q plus 0.3 gamma B and R. For the square footing, QF is equal to gamma D and Q plus 0.4 gamma B and R. Rectangular footing, QF is equal to gamma D and Q plus 0.4 gamma B and R. And the strip footing, QF is equal to gamma D and Q plus half gamma B and R. So these are the formulas according to their shape and according to the soil strata, according to the nature of soil and the characteristics of soil for the bearing capacity evaluation, terzaghis equations.